in some of those high-end CPUs, you remove a semicolon, or just add a semicolon, then hit compile again, and it takes you around 20 minutes until you start to get some results from the simulation. And that's the state-of-the-art commercial tools, running with SSD and as many terabytes as memory as you want. So what I started to do is to do papers, because I'm academic, so you have to have the papers for the PhD students. How to do incremental compiler, how to do incremental place and route, synthesis, parallelize, so typical academic work to have publication, how to get ideas. And then I was going through the industry and talking to Intel, Synopsys, Cadence. It's like, oh, why don't we implement some of those things? Or why don't we do some of the things? So they always liked the idea, but it was very difficult to get any traction to get those things implemented. And it was, or the code base was very messy, or it was against the business model, because if you do incremental, well, how do I charge for my license? So it was not in their interest. It was not on their main focus to do it. So then it was like, okay, we have to have an impact here. I have to switch to the tool and give more importance to the tool. Try to have a competing tool in a subset of the flow, because you can compete easily for the whole flow. So then it started in 2018, so I started to work more on the tool. So because I want to have the tool, you need to do that in order to have the impact, and it can be an alternative, but combined with the paper ideas. So this one is the two evolved more combined. While ISES was the papers, create a simulator, Dromaggio was that we did the tool and then the papers came. Here is, I have to keep thinking, okay, how do I get the PhD student to get a paper, but have master students to keep helping on the project, maybe have undergrad students, and now I'm trying to get a post-professional programmer to help on the flow, things like that. So it's a little more complicated, but that's sort of what I'm trying to do. So in the LifeHD is a summary, it's a compiler for hardware, so we have a goal of productivity, so that's what makes a difference with the other tools. It has some similarities with Circuit, it has some similarities with JOSES. But in general, from a faculty point of view, we have the paper tool. And the tool is the open source, but we need the papers for the students. It's just a PhD student. So this is the summary of what I was mentioning, the things, but we have to be careful with that. So if I do a Wild West view of what is my experience with open source, so one thing still feels like the Wild West. That's why I put the good, the bad, and the ugly. So the good is that I really enjoyed working open source. I've been doing that even since I was an undergrad. I see that you have an impact for the thing. The communities tend to be quite nice, much more friendly than some of the reviewers that you might have paper-wise. And you can have an impact, because if the tool gets used and is stable enough, then you see a lot of people using it. Like Dromaggio, the CBA6 that we were talking yesterday for verification is one of the tools is used for co-simulation. ISES has a lot of citations for using papers that they are using for work. LifeHD still not ready, so for the moment no impact. But what is the bad? So the thing that you must balance as a faculty is the papers versus the tools. And usually if your student wants to go to academia, he needs to have many papers. So you have to ask, do you want to go to academia or do you want to go to industry? You want to go to academia, you really have to focus on the papers, because that's the way our system works, an academic acceptance. If you want to go for industry, then it doesn't matter, you still need the papers, but you can have more heavy in tools. But there is a balance. I try to use master students to help bring infrastructure, but they have a short time. They work only for a couple of quarters, so it's difficult to keep the whole flow working there. So funding is a bit harder, but there are some funding sources as long as there are students. Trying to explore options for funding on professional programmers, and maybe in a year I'll tell you if I'm easy or hard But there's some funding sources for tool size. Now, what is the ugly is that working on the tools takes time. Anything that you will consume time. The academic recognition for tools is not there. So you have a paper, it's very easy to do. In your merit review, when you do reviews every year in academic, it's very easy. Oh, I have a paper, it's a good thing. If you have work on a tool, it's like, what is this? That's an op. It has no recognition. So that's the part that is not, you have to be aware. As a faculty, the review process inside the universities does not appreciate at all, or doesn't evaluate the tool side, unless it's an extremely popular tool that it comes on the news or something like that. So it shows up in CNN news, something like that, then yes. But unless it's a ridiculously popular tool, no. So my suggestions, if I'm a little bit older now, if I were, while I was, but so those were my suggestions, but it will be for someone else. While I was an assistant prof, I would focus on papers. It's okay to have tools, but not the main focus. While I'm associate prof, you can start to focus on whatever you want a little bit more. And papers and tools are okay. But you're in full prof, I think that you should try to do a little more focus on tools. And the thing is, because you can take more risks. You can try to have a tool that maybe has impact, maybe no one uses it, so it has no impact. But it's okay. But you still need to do papers. It's not that you can disappear from the paper domain because the students need it. And the impact on the tools is very difficult to predict when you build it. Like the one I was doing for teaching Romaggio, I didn't think it was going to be used for academia and papers and things. But then it happens. So sometimes you do it, you build it, you open source, and suddenly a lot of people start to come that you didn't expect. Sometimes you have when you build a tool, you might have the feeling, oh, this has no impact. But does it have impact? It's difficult to predict many times. So this is the summary of my talk. I think I was having 15 minutes, so damn. Yeah, any question?
Thank you very much, Jose. Is this on? There we go. Thank you, Jose. I will pass over here to Graham.
Sure. Thanks very much. How do you negotiate? So there's three stakeholders for IP, right? There's the university, there's you, and there's the students. And how do you negotiate IP ownership, especially when a tool has already been built and you're kind of exfiltrating it?
So usually the students are working for you as a GSR and you're providing funding. So they don't own the IP. The university, you have to negotiate that they let you open source. For example, in Santa Cruz, at the beginning, they were okay with BSD license. It took me a little bit of effort to get an Apache license for the project that we're doing. Because they are concerned about, oh, are you granting patents from other things that you don't know what you are granting? But after negotiating a little bit with the patent office, then I can have Apache license. That is what I wanted. And then they got grandfather. Now this project is there. They're not going to go back and take it back. So I tried to do Apache in my case.
Just to clarify, so the students, most universities would be very happy if something became a spin-off, for example. And in that case, is it still true that the students wouldn't maintain ownership? I mean, your choice to open source something effectively excludes the students from taking advantage of something that might have.
Well, it's an Apache license, so they can take it and they can commercialize and do whatever they want after.
Right. Okay, but in the case that the tool already exists and you're figuring out how best to get it to an open source status, you're making these decisions on behalf of the students, and so they still are stakeholders.
Well, if you are getting code from outside, you have to talk to the one who has for example, ESAS. When we started with this, we started as a GPL license because it was what it was popular at the time. So there were several contributors for the project, and I wanted to change to a BSD. So I just contacted them and it's like, are you okay? All the contribution I switched to BSD, and they told me yes. I don't know, whatever you want to do. It's like, okay, so I'm switching to BSD. So I contact the ones who were contributors and tell me, okay, so I switched to a BSD license.
Thank you.
Do you think there's a way to change the incentives by making tools more citable?
So I've been thinking about that, and one trick is to do an archive paper, because what is the problem? You make a paper, so we always make a paper and you say, oh, cite this for the paper. But then there is going to be some new students who keep working on the tool. It's not that it's dead. And then they don't get recognition. So what I was thinking is that archive, because it allows you to do versions of the paper, might be a good thing as the paper for citation. But archive will not have a high recognition as a, oh, this is a top conference. No. So there has to be, it will be good if we have an external thing that says, like, rank tools by giving stars, like a GitHub stars or something like that. But it's like, oh, this is a perfect paper. This is a tool that is very useful, and so you can get recognition. It might be a way to do something like that.
So you think stars are going to count towards tenure?
I think that you can put it there. I don't know how much they are going to say, like, well, whatever.
Great talk. I just had a question. In my experience with academic open source, there's a big challenge that other academic groups tend to build their own thing rather than reuse, your academic projects or something. Do you have any experience with that?
So there is, they say you have 3 faculty in a room, you have the 5 opinions. No? So there is faculty who wants to have the student to reproduce the simulator and infrastructure. And the reason is because it's the learning experience, how this infrastructure works. So there's going to be a lot of replication of the tool, because it's not so much for the tool, it's because to learn, the student has to learn. But when the tool has some size, it's like you cannot do it, or you're going to do a very bad job. I like the idea that there are different tools that are sort of overlapping, because otherwise you optimize too much for one thing. Like, for example, the LifeSD. The typical question, oh, why are you doing LifeSD? Why not Circuit? Why not to do JOSES and you patch this? They have very different internals. You can have very different optimizations, and some of them will make very difficult to do some things that with the other ones you can do and explore. So some degree of replication I think is good. Now, every student doing the whole tool by itself, unless it's something small for learning, I will not do that.
Well, I think we can stop here. Thank you, Jose. We thank our speaker once again.